My name is Vladik Romanovsky. I'm one of the maintainers of the KubeVirt project. And today I would like to share some of the progress that KubeVirt had over the past year, both in terms of features, but also the community work. For those who are not familiar, KubeVirt is an operator that extends the Kubernetes API server to allow users to run virtual machines alongside the pods. And this is all using the same familiar Kubernetes API. We run the QEMU process that emulates the virtual machine inside a container, as you would normally do with any other user space application. It's often viewed, KubeVirt is often viewed by some as a replacement for other virtualization platforms. However, KubeVirt is significantly much more. It integrates deeply with Kubernetes, and we reuse multiple native Kubernetes components in KubeVirt. And KubeVirt is actually part of a broader Kubernetes ecosystem where it can be a component in a pipeline or provide a way to craft interesting solutions using it. One such solution is the KubeVirt provider for cluster API, where KubeVirt virtual machines are being used as nodes for virtual Kubernetes clusters. This was a good year for KubeVirt in general. Lots of different companies were interested in it, and here's a compilation of some that added themselves as adopters. In terms of community work, as KubeVirt matures, code quality takes the central stage, and it becomes a hot topic in the community. This year, we have been also working on evolving our SIGs and creating working groups and sub-projects. And this is not just in terms of code separation to different areas, but also we went ahead and created these groups of people, groups of contributors that are interested in a specific area and will become expert in it, but also they will take responsibility for fixing bugs in that area and generally maintaining quality there. This step also allows our contributors to evolve within the project. So anywhere from being reviewers, contributors can become approvers in a specific SIG and then become chairs. Afterwards, they can grow in being root level approver for the whole project, but also eventually they can grow to become maintainers. This year, we also established our feature lifecycle policy, something that we didn't have before. And similar to Kubernetes, new features that are coming into KubeVirt, these would go through maturity stages from alpha to beta, and then when all the conditions are met, these will become publicly available. As you know, KubeVirt, we have also been working on evolving our design proposals, and we still do. And this is not just in terms of the mechanics of the design proposals, but also we believe that reviewing these proposals and accepting those before the development cycle begins will allow us to create a roadmap and a clear view of features that we're committed to deliver by the end of the development cycle. This will kind of serve as a priority for features through this development cycle. And hopefully that will allow us to focus contributions and review efforts mainly towards the features that needed the most attention. This year, we also have been looking at graduation. And as you know, KubeVirt is currently in an incubation stage. However, KubeVirt is already a very mature project. And It's the second year that we were looking at graduation. However, this year some more requirements have been added, and more paperwork is kind of needed from our side. And however, we are determined to complete this process. Another interesting addition this year was that we started using the Dosobot. Dosobot is an AI platform that that help us with triaging issues. It indexes all of our Git repository, including issues and documentation. And it also serves as kind of a first responder to users, where it can point to a link of a resolved issue already, and also point to a piece of documentation. But also there are some interesting anecdotes with it, where recently a user was complaining about the race condition that he found in our code. And Dosobot responded with a generated code that actually fixes this issue, and this was a very pleasant surprise. There are hits and misses, and I think more misses with it, but as it evolves, I hope that it will help us even more. This year, we also had our KubeVirt summit. We have it every year for a couple of years now. And it's a virtual summit, and I invite you to follow the QR code to our YouTube page, where some of the talks are captured. And this year, we've doubled the amount of participants. Hopefully next year, there will be even more interested people. We also participated this year in GSOC. It's a Google Summer of Code, and we've doubled the amount of projects and the amount of mentors, and kudos for everyone who was involved in this. This year we also had 3 releases, and generally we're trying to stick with the Kubernetes release cadence with a slight delay for stabilization. And there are lots of features that have been delivered this year. And I will not go through all of them. I will touch on some important ones in the next slides. But I invite you to follow the QR code to see the blog posts about each of them. The last release that was announced a couple of days ago is mainly focusing stabilization. And there were lots of fixes that went into this release. It also focuses on one security concern that was raised, and it comes with alongside some of the small amount of important features as well. One of the features that I would like to touch deeply on is the fact that we've turned our virtual machine object into live updatable. Until that change, any change to the VM object would have to be staged, and meaning the users would have to turn down their virtual machine and start it over again for these changes to propagate from the VM object to the running instance of the virtual machine. As you can imagine, there are fields on the VM object that don't necessarily require a restart, and we wanted to change that as well. At that time, we also delivered several hot plug mechanisms. Hot plug for CPU and memory, hot plug for network interfaces, and a hot plug for disks and volumes. However, all of these mechanisms, they had different APIs to them. Some of them were declarative, some were imperative using a sub-resource, and we wanted to unify all of this and bring all of these changes together into the VM object. And what we've done, we introduced a cluster-wide tunable that effectively turns our VM objects into live updatable. And from there, fields that can be immediately propagated, such as labels and annotation and others, can do so. And changes to CPU and memory, for example, would trigger a hot plug. And other changes that affect the guest ABI, these would still require a restart, and the user would be notified accordingly. Building on this functionality, we also developed a volume migration mechanism this year, and I invite you to follow the QR code to a much deeper conversation on this feature that includes a demo and a discussion about potential use cases. What I will say here is that, as I mentioned before, changes to a VM object, especially in the area of volumes. For example, if somebody wants to change the persistent volume claims on a VM, this would trigger a migration. Although there are different strategies on how to react to such change, it could be a hot plug or a replacement of these. We'll focus on migration here. And a migration is needed because if you remember the pod objects in Kubernetes, at the moment these are immutable, and we cannot simply change the volumes that are attached to pods. Therefore, we need to create a target pod with the new volumes attached to it with a similar spec. And live migration is actually doing exactly that for us. So the flow works in a way that a change on the VM object would be recognized as such, and then the workload updater controller would trigger a migration to create a target pod with the new volumes attached, and then the content of the virtual machine would be transferred from the source pod to the newly created one. And those who will be mainly interested in this feature are users who are willing to migrate, to move their VMs from one storage class to another. And there are many reasons for doing so, one of which is for example, the underlying storage needs to go through a maintenance, and the administrator wants to move all of these workloads to another storage without any interruptions. Another use case, for example, is that some users want to move from block storage to file system volumes, and this process allows this as well. This year, we also made an important change in our Virt-handler component. The Virt-handler is the node component, and until recently, it was very powerful. It was able to see all the virtual machine instance objects in the cluster. It was able to process them, and it could also see the node objects and actually change them. And even before that change, we already restricted the Virt-handler from touching any virtual machine objects that are not running on that specific node where the Virt-handler itself was running. And with this new change, we introduced a validation admission policy that actually prevents a Virt-handler from modifying node specs. And we also restricted and prevented from doing anything to labels and annotations that were not owned by KubeVirt, meaning were put there by other components, for example. During this year, we also developed another operator that solves a fundamental problem in KubeVirt. And this is an application of Aware Quota. What it does, it presents an alternative way for managing quota in Kubernetes. And the fundamental problem that it solves in KubeVirt is that it allows us to avoid, I'll say it differently. Our KubeVirt system upgrades, they rely on live migration. And this live migration can be blocked easily by not having enough quota in the system. And normally, resource quota is being installed in the namespace, and it consumes resources and limits resources such as CPU and memory. And on the other hand, as I said, we perform system upgrades through live migration. And as part of live migration, we create a target pod, as I mentioned before, that consumes the same amount of resources as the source pod. And then eventually, what happens is that there's a point in time that we consume double the amount of resources that are needed for running a virtual machine. And if there's not enough quota in the system, that target pod cannot be admitted. And eventually, the whole system upgrade and other important operations can fail. So this new operator resolves this issue. Another problem that it solves for us is related to the fact that other virtualization platforms, they build their users only for the virtual resources that they consume. And all the infrastructure overhead that is effectively being introduced by the virtualization stack itself, it's being ignored and has nothing to do with the user. In KubeVirt, we cannot simply ignore this overhead, and we must list it, and it's being counted towards the user quota. So this operator solves this problem for us. And it relies mainly on a feature in Kubernetes that was recently introduced. It's called pod scheduling readiness, that effectively adds a new field to a pod spec. It's called the scheduling gate. And when this gate is set, the pod will be prevented from scheduling, and it will be kind of suspended until the moment the gate is lifted. And once it's lifted, the pod will continue scheduling to the nodes. And we can rely on this mainly because both of our VM creation flow and the migration flow, eventually they create pods. And when these pods are committed to the system, the AQ webhook would add this scheduling gate to them, effectively suspending them. And at that time, the AQ controller would be able to recalculate the quota in the system and would check if the suspended pods can fit into the remaining quota. If they do, the gate will be lifted, and these will be scheduled to the nodes. Same way for live migration, when we create this target pod would be recognized by the application Aware Quota controller that it's actually being part of already running virtual machine. And since we don't want to use to build the users twice, that target pod will be scheduled to the node immediately, effectively unblocking live migrations. Some benefits that we get by using this operator. First of all, that we remove a bottleneck from the API server where previously a resource quota was calculated. And because we remove this bottleneck, the API server can spend more time processing requests than calculating quota. Another benefit is that the API that is coming with the application Aware Quota allow us to see a cluster-wide consumption of quota, something that we couldn't get with the traditional resource quota in Kubernetes, where we could see resources consumed only per specific namespace. Another benefit that we get with this operator is that it's not necessarily have to work with KubeVirt at all. It can work with other objects and other operators, and that's because we allow cluster administrators to craft their own policies of how they want to calculate quota in the system. And they could easily plug these policies into this operator. In terms of future work, as you've seen, we rely quite heavily on live migration. And there are some ideas of how to improve both the speeds of live migration and its reliability. And going forward, we are going to invest in that area. Over the years, we also removed some of the some of the privileged operations away from the Virt launcher pod. Virt launcher pod is the one that actually runs the virtual machine. And we delegated this privileged operation to our node component that was already privileged. And that allowed us to run this Virt launcher pod entirely unprivileged, rootless, and could be completely untrusted component. But by doing so, we increased our dependency on Virt-handler actually being present during all kinds of operations, such as creation of the VM. And one way to reduce a little bit of this dependency is by using these new native components that are being introduced in Kubernetes, such as CI volumes and artifacts. And this will allow us to stop using dedicated KubeVirt components, such as container disks, and use these when these will become available and stable in Kubernetes. This year, there were some IO thread optimization work that has been done in QEMU and libvirt. And we intend to use this and incorporate those into KubeVirt this year. Another a feature that is going to land soon is will allow our cluster administrators to migrate workloads to specific nodes. This is something that wasn't permitted previously, and now it's going to land soon. We are also looking at integration with DRA, which is the dynamic resource allocation mechanism that is going to be stable soon in Kubernetes. Our friends from NVIDIA were recently giving a talk about how they envision this integration with of DRA with KubeVirt, and the benefit that we will get from using this mechanism is, first of all, it will allow us to repurpose some of the hardware that we assign for virtual machines. For example, a GPU that is assigned to a virtual machine on the allocation can be repurposed to use with pods. In the same way we could do with virtual GPUs as well. Another benefit that we get from using this is that the DRA drivers, they are pluggable, and we can allow our third-party partners to actually develop their own and maintain their own, and then simply plug those into back into KubeVirt. Another very critical component for us that is being currently developed in Kubernetes, and we eager to integrate with, is swap. Unfortunately, it didn't come to maturity yet in Kubernetes, but our KubeVirt engineers are actively working directly in Kubernetes to stabilize this and to allow this integration to happen. And this will allow our virtual machine to have more flexibility when they when they consume most of the resources at the peak of their performance. This is all for me, and thank you very much for listening. I'll be happy to take your questions. Thank you.
So just wondering, thanks for sharing the updates. Just wondering, is there any future work that possibly relevant to networking interface, for example, like a way to add multiple network interfaces for VM, and not only the default bridge the network inside the VM, sometimes we need to provide directly attached kind of VM like other legacy platform, OpenStack or VMware stuff. So I'm just wondering about the networking part.
Yes, I actually didn't manage it's here, but because of like too many things. But in general, KubeVirt allows pluggable network interfaces. So an interface could be developed as a sidecar, and then it could be used with the virtual machine. So that sidecar, it effectively, as it is today, it modifies the underlying library domain XML and allows an introduction of a new interface. But we're looking at somehow enhancing this process, and not just modifying the XML, but actually creating an interface and then moving it into the main Virt launcher container.
You guys are also considering kind of live migration as well regarding that multiple interface, meaning that when you try to live migrate to those VM that has multiple interfaces and still supposed to be continue to be working, right? So
yes, effectively during live migration, we are creating an identical copy on the target, and if there are, and effectively all the pod is being copied with its all other containers that are in that pod being copied and recreated on the target. So if there are pluggable interfaces there, this should be connected there as well. I mean, there are all kinds of nuances. It depends on the CNI and whatnot. So it's not an easy question to answer here. Yeah.
Does KubeVirt integrate with Spire for workload identity management?
For Spino?
Spire, the SPIFFE protocol?
I'm not sure. I don't know.
It's fine.
I have a question about the Windows OS. So what are the enhancements you're working on making the Windows guest OS, working smoothly?
Sorry. So we already support Windows guest OS pretty well. There are drivers, Virt-handler drivers for Windows. But as we go, we also develop our support for VBS. And yeah, there are all kind of nuances for this nested virtualization aspect of Windows. But yeah, there are some.
How is Microsoft partnering with you on this, or?
How is Microsoft?
Is Microsoft fully aligned on all this different?
Yes, as you've seen, Microsoft is one of the adopters of KubeVirt, okay. And yeah, we are happy for their contribution as well.
Thank
you. I was curious on the resource quota issues you're running into, and I was wondering if you all have looked into Q. Because you actually do support pod readiness gates with Q, and I know that Q was kind of created to overcome a lot of existing problems with resource quotas.
So it's the dynamic quota?
It's kind of the batch scheduling kind of thing.
Well, Q supports pods also, so it does set scheduling gates at that level too. And I was just curious if you have been thinking about more people requesting virtual machines than you have capacity on your cluster. And I know you're probably using resource quotas and that, but it sounds like it's kind of a little bit inflexible.
Yeah, we didn't look into this, but yeah, I'll be happy to take it with me.
To the Spiffy Spire question, I've got a prototype of injecting Spiffy stuff in through VSOC.
Yeah.
And it's working with KubeVirt. So if you want to look on the Spiffy Slack channel and talk about it, there's options.
Perfect.
Hi. So I have a question about the liveness of the VM during live migration. So does KubeVirt introduce any additional overhead in terms of live migration when compared to the baseline? Because I couldn't find any numbers online, so it'd be great if we could.
Are you speaking about like a CPU consumption and memory consumption, or like a network overhead and things like this?
So specifically memory, and also the network to the downtime and the total migration time. So
downtime. So I mean, it really depends on the. I guess on the on CNI what is being used. Sorry, are you asking about the networking aspect of it? Just the. Maybe.
No. When you mean live migration, it's
Yeah.
the downtime of the VM. That is the application running inside the VM.
Yeah.
So my question is, how live is it when you do the live migration?
So it's as live as it could be. The downtime is reduced to minimum, and if this is a pre-copy migration, then the downtime is about 400 milliseconds and maybe even less. So it doesn't disconnect the clients in the middle. Although there are, from KubeVirt perspective, it doesn't disconnect, but it really the integration in the broader ecosystem. So how clients are being connected to Kubernetes, and then this is being routed to KubeVirt. That also can, but in general, in terms of VM workload, there's not much downtime. There are a few strategies of how to migrate. There's a pre-copy that may take more time, and there's a post-copy where we do a little bit of pre-copy, and then, we do pre-copy at the beginning, and then we switch to post-copy where the target is actually becoming the active part, and then we copy the pages from the source, and like in a lazy copy. But in terms of downtime.
Thanks.
Sure. Any other questions? All right, thank you very much.